Good day, students. You are welcome to Scholars Universal School online class. This is mathematics, and today's topic will be continuation of the past 2 weeks topic, that is trigonometry. And today, we are going to consider sine and cosine graphs. But before we go on, remember that mathematics is the simplest subject you can always enjoy and always put your interest in it. Then, remember to subscribe at no cost on our YouTube channel, Happy Learning Time, Scholars Teachers Care, or Scholars Teachers Care. Let us first take a look at the sine graph. We'll recall that in the past classes, especially last week, we were able to look into the Cartesian coordinates. And in the Cartesian coordinates, we were able to consider the fact that sine and cosine and tan are positive in some quadrants but negative in some other quadrants. And that brought the popular saying that all scholars, teachers care. You recall that from the all is in the first quadrant, which simply means that all the trigonometrical ratios are positive in the first quadrant. And that in the second quadrant, is only sine that is positive. In the third quadrant, only tangent is positive. And in the fourth quadrant, it is only cosine that is positive. So that brought it again that all scholars, teachers care. And we're going to see the practical implication of this today in plotting our sine and cosine graph. First, let's consider the sine graph. Let's assume that we're given the equation that y equals to sine theta, and that we should choose our value from theta equals to 30 degrees, 60, 90, 120, 150, 180, 210, 240, 270, up to 360 degree, in that order. Now, if we have this, so just like we always do when we are plotting our normal graphs, when we plot our normal graph and we have an equation like this, usually in place of theta here we'll have x, and then we can just put the value of x there, and we now insert the value into the equation to get the value of y. So in the same manner, we're going to do this, whereby each of this value starting from 30 degree, of course we will even start from 0 degree. We are not really much bothered about 0 here, because if we put 0 here and we now have y equals to sine 0, we're still going to get 0. So that will be treated separately. But from this table now, when theta equals to 30 degree, for example, so recall, you can use your 4 figures table anyway. So you see that sine 30 degree will give you 0.5, sine 60 degree will give you 0.87, sine 90 degree will give you 1.0, sine 120 degree will give you 0.87, sine 150 degree 0.5, 180 0, sine 210 degree will give you minus 0.5. Recall that 210 is in the third quadrant, and you have to get the acute form. You recall the acute form of angles. We have to get the acute form of all angles that are greater than 90 degree. So before you can actually get the trigonometric ratio. And you recall here that you see here that when we have 120 degree, we have to subtract it from 180 degree, and that gives us 60 degree. Cos 60, sine 60 degree gives us 0.87. And when we subtracted this from 80 degree, 180 degree, we're having 0.5 as the sine of the remnant angles. The acute form of this angle is 30 degree, and sine 30 degree is 0.5. Then here sine 180 degree is 0. But one thing you should observe here is that despite the fact that the values are greater than 90 degree, we still have positive values for sine here. Sine 120 degree is positive, sine 150 degree is also positive, because sine is positive in the second quadrant, and 120 degree, 150 degree, they are all in, that is, both of them are in the second quadrant. Remember, all scholars teachers care. Now, after 180 degree, we get to the third quadrant, and here now this value is greater than 180 degree. So to get the acute form of this 210, we have to subtract 180 degree from 210, and that gives us 30 degree. Sine 30 degree is expected to be 0.5, but because sine is now in the third quadrant, because it is now in the third quadrant, that is 210 is in the third quadrant, so sine is negative in the third quadrant, and that is why we have sine 210 equals to minus 0.5. If we proceed to 240 degree, 240 degree is still in the third quadrant, and you now see that if you subtract 180 degree from this 240 degree, you have 60 degree left. That is the acute form. And if you need to find the sine of 60 degree, so you get 0.87 from your four figures table. Is actually 0.866, but because we are going to use it to plot graph, so we approximate it to 0.87. And because this value 240 is in the top quadrant, then we have to assign it a negative value. So we have minus 0.87 as the sine of 240 degree. If you get to the third one, this is 270 degree. And for 270 degree, 270 degree is still in the third quadrant, and sine 270 degree, so sine 270 degree should give us minus 1.0. This is because if you subtract 180 degree from 270 degree, you have 90 left. So the acute form of 270 degree could be taken as 90 degree, and sine 90 degree equals to 1. So, but because it is in the third quadrant, so we have to give the negative value. Remember, all scholars teachers care. Then when you get to 300, 330 and 360 degree, all these values are in the fourth quadrant. So the sign of any value here in the fourth quadrant will always be negative. Sine 300 degree is negative, sine 330 degree is negative. In order to get sine 300 degree, because it's now greater than 270 degree, you have to subtract it from 360 degree. So 360 degree minus 300 will give you 60 degree. And if you find sine 60 degree, you get 0.87. But because 300 is in the fourth quadrant, remember, all scholars teachers care, so we have to assign it a negative value, because sine is not positive in the fourth quadrant. It is only positive in the first and the second quadrant. Then when you get to 330, if you subtract 330 from 360, you get 30 degree. And if you find the sine of 30 degrees, 0.5. So the negative is assigned because it is in the fourth quadrant. All scholars teachers care. So 360 degrees, sine 360 degree is 0. This, if you have challenges in getting it right, that is how we got the acute form of all this angle from 120 to 360 degree, please refer to your last week video on trigonometry 2, where we treated the fourth quadrant, where we treated the all scholars teachers care, where we knew that the first quadrant, all of them are positive, the second quadrant only sine is positive, the third quadrant only tan is positive, while the fourth quadrant only cos is positive. So please refer to that class. So we have been able to get the value of sine theta here, and that is shown in pink color here. So you can now put your y here, because y is whatever you get for sine theta. Y is whatever you get for sine theta, because this equation says that y equals to sine theta. So let us see what happened. We can see y equals to sine theta. When sine theta is 0.5, y is 0.5, 0.87, 0.87, 1.0, 1.0. Then when sine theta is 0.87, y is also 0.87. When it is minus 1 here, it is also minus 1 here. Minus 0.87 here, it's still minus 0.087. And here, when it is 0, y is also 0, because y equals to sine theta. So with this, we have got the value of theta. And sorry, we have used the value of theta, which are 30 degree to 360 degree in that order. We have used it to get sine theta. And having got sine theta, automatically we have got our value of y. So let us proceed. We can now plot this on a graph. And for this graph, the first thing we have to take note of is that when that we're going to we're going to consider the table for y equals to sine theta, which we constructed above, that is here. So we're going to consider this table, and for this table now, though the value of theta as 0 is not shown there, but it is significant. It is important that we know that when theta is 0, y will also be 0, because sine 0 degree is 0. So it is important to know, because there's no way we plot the sine graph that it will not start from the point 0. And we are going to, for this graph, we're going to choose our values this way. That is, we are going to choose the value of y as 4 centimeter. That is for the y-axis. That is the sine theta axis, y-axis. 4 centimeter will represent 1 unit, and for x-axis, that is the theta axis. So 1 centimeter will represent 30 degree. So let's see how it goes. This is the copy of the table we have in the previous slide. And let us now draw our axis. So let us see it, the way it goes. This is our y-axis, where y equals to sine theta. Then we have our x-axis, which represents the theta. Recall that theta stands for x here. And let us just now let us calibrate our axis. So we have calibrated our x-axis, and we are starting from this point 0, 0. That is when value of y is 0 and when value of theta is also 0. So that is the origin. Then we can see from here, looking at this graph from here up to this place, we are having 4 centimeter. This is 1, 2, 3, 4. So we are having 4 centimeter. And then when we have 4 centimeters now, you know that for 4 centimeter, 5 small boxes make 1 centimeter. Therefore means that we will have up to 20 small boxes. If you count all these small boxes like this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 up to 0.5, you have another 10 up to 1 from 0.5. So all of them, you have 20 small boxes. Now each small box now will represent, okay, 2 small boxes will now represent 0.1. So this is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8. So, but this place now will be 0.9 and 0.87, because 0.87 is in our value here, that's why we are indicating it here. And this is 1. So the maximum we got for y-axis from this table is 1. So we may not bother ourselves going beyond 1. So when we have it this way, so we have calibrated the positive axis of y, that is of sine theta. Let us now, the same thing happens at the negative axis, where we have from 0, 0 up to -1. Then for x-axis, we want to use 1 centimeter to represent 30°, which means since we are having 5 small boxes in 1 centimeter, it means each of the small box will represent 6°. So let us see what happens here. We have calibrated our x-axis here from 30°, in fact from 0° to 360°. We have actually worked from 30° to 360°. Then this is the origin. So this 0 is for x-axis and that's for theta axis, and this 0 is for the y-axis, which is sine theta axis. So let us now see. We can now plot our graph. When we have 30° here, when theta is 30°, y equals to 0.5. Let us see how it goes. 30°, 0.5. So that is what we have. So this is our point here. If you are confused about what we have just done, so let us see again. When theta is 30°, y equals to 0.5. 30°, 0.5. So this is the point. We'll plot our point here. So let us see. Then when it is 60°, when theta is 60°, y equals to 0.87. So we come here, 0.87. Actually, this place is 0.9. So this place is 0.85. This place is 0.8. This one is 0.8. We can see that. Then we have 0.85 here, 85 here, and this is 0.9. So 0.87 is between 0.9 and 0.85. So we plot it in the middle here. So let us see. So we can see it there. Then the next one, when it is 90°, theta is 90°, this one becomes 1, that's x is 1. So this is 90°, trace it up. This is where it intersects the line from y-axis. So it means that from this, that's if you look at it this way, from here to here, so it means that this is the point where theta equals to 90° and y equals to 1. So let us plot it, and the same way we'll plot for 120, which is 0.87 again. So 120, 0.87 will be somewhere here. So we plot for 150 here. Just look at it. This is 150°. So this is where it's 0.5, like this. You can see. So we're going to plot this point. So let us get to 180°. On getting to 180° here, we'll see that from 180°, y equals to 0, 180, 0. So this is line of 0° for y. Along x-axis or along the theta axis here, y is 0. So this is the point 0. We'll plot it. We use this pink dot to denote all the points that lie on 0 point, that's where y is equal to 0. That is where the point falls on the theta axis. So let us proceed. We now go to 210. This is the dot for 210. You know, when it is 210, the value of y equals to minus 0.5. See, minus 0.5. So just like we have it here, okay, we have it as minus 0.5. This is minus 0.5. So we have plotted it. We go to 240. If you go to 240, so we are having minus 0.787. This is minus 0.87. Just trace it. Just trace it to where you have 240 here. So this is where, this is the point here. You can see the point here. So let us plot it. So let us now plot for 270 and minus 1. So this is line for minus 1 and this is line for 270. So it means that this is 270 here and this is line for minus 1. So here we can see it here, minus 1. So this is the point here. So let us plot it. So let us now go to 300. Getting to 300, so you see that at 300 is coming back to minus 0.87. This is minus 0.87. So this is 300. So it means that the dot will be somewhere here. We will now plot here. Can you see that? So let us now get to 300. We have plotted 300. So let us now get to 330. For 330 degree, we still have minus 0.5. This is line of minus 0.5 this way, and this is where 330 is. This is 330, and this is the line that goes to 0.5. See, 0.5, this line of 0.5, and this is the line of 30 degree. If you see, look at, if you measure it upward. So the point will be here. I hope you can get this. If you cannot get it, you can pause and review the video so you can see the dots. So let us now go to 360. At 360 now, y equals to 0. That's when theta equals to 360, y equals to 0. So, as usual, this line is along this line, along this horizontal axis, along this theta axis, or what we popularly known as x-axis. Y is always 0 there. So this is the point here where theta is 360 and y equals to 0. So let us plot that. So we have been able to plot that. And so let us look at it again. So we have been able to plot 360 degree here and y equals to 0, theta equals to 360 degree. So we are going to join this curve. You have the option of joining from here to this place, or you have the option again of joining from here to this place. Of course, no examiner will ask you how did you join your curves. All you just need to do is to ensure that you have a very smooth curve. Then, if it will be difficult for you to continue at a stretch like that, you may just plot for negative axis first. That is from here, the one below here, you may just join them first. Then from this dot again, you join for the top axis. You can also review it this way, that you may join from here like this to this place. Then you come here and join from here to here. Recall again, I can decide also to join from here to here and come here again and join from here to here. So let us see. We are going to plot our curve now. Look at how it's going to come out, and you will have to try that on your own as well. Can we see that? Yes. We are now having a perfect curve, and this curve is that of sine graph. Can you see it that way? So y equals to sine theta. This is the graph of y equals to sine theta. So anywhere you see it, equals to sine theta. And the maximum value here in this graph is, if you look at it, the maximum value is 1 and the minimum value is minus 1 here. That is, this is the lowest value, which is the minimum value. This is the highest value, which is the maximum value. So we can always do this without much ado. So let us now consider the graph for cosine. If we assume that, if we are told that, okay, y equals to cos theta, and that we should plot the graph of y equals to cos theta just as we did for sine theta. So we need to plot our table. We need to plot our table considering the value of theta from 30° to 360°. Then we have the value for cos also. You can recall cos 30° will give you 0.87, cos 60° will give you 0.5, cos 90 is 0, cos 120°. You know, cos 120° is in the second quadrant, and it is only sine that is positive in the second quadrant. So cos and tan are negative. So this is cos, and that is why it is negative. So we are having minus 0.5. So recall again that you need to get the acute value of any angle that is bigger than 90° before you can get the trigonometric ratio. So you have 120°, and if you subtract that from 180°, so you get 60°, and cos of 60°, so 60° is the acute form of 120°, and cos of 120° or cos 60° in the second quadrant is minus 0.5. So cos 150° is in the second quadrant, and if you find the acute form is 30. By subtracting it from 180, you get 30. So 30° in the second quadrant will give you minus 0.87. Recall that we are having 30° here, which is in the first quadrant, that is 0.87. No negative sign, it is plus 0.87. But for this, so the acute form of 150, which is in the second quadrant, will give you minus 0.87. Recall that only sine is positive in the second quadrant, cos is negative. So for 180°, so cos will give us minus 1, cos 180° equals to minus 1. Cos 210° equals to minus 0.87. Recall that 210° is in the third quadrant, and for you to get the acute form of the angle in the third quadrant, you have to subtract 180° from it. So by subtracting 180° from 210, you have 30°. But because that 30° now falls in the third quadrant, so you have it as negative for cos. Because cos is negative, cosine is negative in the third quadrant. So let us now go to 240. So the same thing that happens to 210 and it will also happen to 240 here. By subtracting 180°, we'll have 60°, and cos 60° will give us minus 0.5. Then we have 270, we have 300, we have 330, and then we have 360 also. So cos 360° equals to 1. Remember that we said cos is positive at the fourth quadrant. That's why we have all scholars teachers here. So you see that 300, 330, and 360 are in the third quadrant, and that is why the value of cos there are positive. So since y equals to cos theta, so y will be equal to cos theta. You can see the value. You just repeat the values here because y is directly equals to cos theta. There's nothing attached. So let us go further. We can now have our graph and choose our scale the way we did for sine theta also. For the graph of sine theta, recall that we said 4 centimeter represent 1 unit, and we're doing the same thing here for cos theta. Also, in the table here, you will see that for this cos theta now, we do not really have 0 there, but 0 is an integral part of the value. It is an important value because no matter how we draw our graph, it will have connection with 0 at the end of the day. So That's why we said that y equals to cos theta, but when theta is equal to 0, what happened? When theta equals to 0, remember cos 0 degree equals to 1. So cos theta will be 1 when theta equals to 0 degree. So we chose our scale. Y equals to, that's 4 centimeter on y axis will represent 1 unit. And which simply means that which simply means that 20 small boxes, because 1 centimeter equals to 5 small boxes. So 20 small boxes will represent 1 unit. And the same thing happens, the same thing that happened in the sine, in the case of sine, is also happening there for cos, whereby we have 1 centimeter representing 30 degree. So which means 5 small boxes represent 30 degree and 1 small box will now represent 6 degree. So let us proceed by having our axis, by having our table. So we have copied our table here, and then we have our axis as well. So the y-axis has been drawn, which is cos theta, y equals to cos theta. So this is the y-axis. So let us have our x-axis. So the x-axis which is representing the theta axis now. Recall that theta is representing x-axis in our conventional x and y coordinate. So if we say x, we are still talking about theta in the case of trigonometry ratio we are dealing with at present. So let us now see. This is angle theta has been located here. So this is the theta axis, otherwise representing the x-axis. Then we can calibrate our axis. Let us now see, starting from the origin 0, 0, just as we have for sine. Then we can now calibrate our x-axis, our y-axis. So we have now calibrated it. So this one 0.87, 0.5, minus 0.5, 0, minus 0.87, and minus 1.0. So we are putting the value of the angles which we are given here for theta. So 330, 360 degree. So we have from 30 degree to 360 degree. So let us now plot our point. First, we deal with the fact that when the value of cos theta, that's cos theta equals to 1 when theta equals to 0. Recall that we said along the x-axis, along this x-axis, which is representing theta axis here, the value of y is 0. By the same way, along the y-axis, the value of x is 0. Invariably, the value of theta is 0 along this vertical y-axis. So we have plotted this place as when theta equals to 0, with this one, when theta equals to 0, cos theta equals to 1 and y equals to 1. So this is when it's 0, y equals to 1. So then the second one, when theta is 30 degree, y equals to 0.87. So this is 0.87 just as we did for sine theta. So our value is going to be somewhere here. And if we continue that way for 60 degree, it will be this place. For 90 degree, recall that cos 90 degree is 0. Although sine 90 degree is 1, but cos 90 degree is 0. So this is the point where we're going to plot. And for 120 degree is minus 0.5. So we have plotted the value for 120 degree here. We know cos 120 degree will give us minus 0.5. For cos 150 degree gives us minus 0.87. And cos 180 degree, what will it give? So let us see. So it gives us minus 1. And for 210, Let us see, it gives us minus 0.87 again here. And for 240, we have this. For 270, because 270 will be 0, which is here. For 300, so let us see, for 300, we're going to have 0.5 again. Because 300, the acute form is 60 degree, and cos 60 degree is 0.5. So we have it here. And for 330 degree, so we have that here as 0.87. So let us see, we plot it here. And for 360 degree, we have 1. This is where 1. So this 360 degree, 1. So we plot it here. So we have been able to plot our points, and we can now join the curve. We have the option of starting from here and go this way and here. We also have the option of coming from here and go this way and here. We have the option of joining them together in any way that is convenient for us. So let us now plot the graph. So we can see that is the graph of cos theta. For example, if you are given that if x equals to theta, and you are now asked to plot the graph of y equals to cos x. So this is the shape, and this is what you are expected to get. So that is why the graph of y equals to cos theta. So we are going to look at this in the next class. So whereby we have y equals to 2 sine 3x. So for all value of x ranging from 0, 15, 30, 45, and so on and so forth. So this is where we have something a bit different from what we had earlier. So here now, these are the value of x. It simply means that instead of having theta before, you are having 3x here. And having 3x here, so you also plot the table just as we did for the other one. And plotting this table now. So when x is 15, 3x is 45. X is 30, 3x is 90, x is 45, 3x is 135. When x is 165, 3x, that's 3 times 165, equals to 495. So you can see it here. So like the same thing for all values of x ranging from 15 to 165. Then you have the 3x ranging from 45 to 495 degrees. So the 2 here, which is a constant, the 2 multiplying sine x, sine 3x, which is a constant, it is a constant and it is for all of them. Then you have sine 3x now. Your 3x here is 45, sine 3x, which is sine 45 is 71, sine 90 is 1, sine 135 is 0.71, sine 180 degree equals to 0. 0.0, sine 225 degree equals to minus 0.71, and so on and so forth. So till you get to sine 495 degree equals to 0.71. Recall that these values, these angles are bigger than 90 degree. From 135 to 495 are bigger than 90 degree. So, and use your knowledge of finding the acute form of all these angles, of the obtuse angles and the reflex angles. So you use your knowledge of finding the acute form to get the acute form value, and you now find the sine of that acute value. And that is what we have done here. The negative is introduced, and the negative tells us the quadrant where it belongs to. Recall that sine is positive in the first quadrant and the second quadrant. It means that all these ones that have negative values are not in the first, they are not in the second quadrant. So we now have y equals to 2 sine x. That means these are sine 3x. So this is sine 3x. 2 multiplied by sine 3x will give us 1.42. 2 multiplied by the value we got here, which is for sine 3x, gives us 2. 2 multiply this gives us this. 2 multiply 0.0 gives us 0.0. 2 multiply minus 0.71 gives us this. And so on till we get to 2 multiplied by 1 for 150 here, and for 450s rather, and you have 2. And 2 multiplied by 0.71 for 495 is also giving you 1.42. And just the way we plotted the graph for sine and cosine earlier, we can also plot the graph of y equals to 2 sine 3x. Recall that when x is also 0, 3x will be 0, and you have y is also equals to 0. Then you can plot your graph as usual. So these are x and y axis. Now this is the table. We have copied the table from the previous slide. And from the previous slide, you recall that we have this table. So we have only taken the value of x and the value of y. So when x is 15 degree, y is 1.42. Up to this place, when x is 150 degree, y equals to 2.0. And when x equals to 150 degree, 165 degree, when x equals to 165 degree, y equals to 1.42. So just like that. Then you recall that here sine 3x will be 0 and y will also be 0 because sine 0 degree is 0. So we also plot our point when 15 at x equals to 15. So we are having 1.42. So this our 1.42 will be around this place. So these are the value for x. So we have our 15 degree plotted with 1.42, then 30 degree plotted with 2.0. Here it will be here. Then the next one, we have 45, and 45 will be plotted with 1.42 again. You can see that the graph is coming down again. For 60, we have 0.0 here. For 75, we have minus 1.42. For 75, it means that we are coming to somewhere here. Somewhere here, you can see that. Then 90 minus 2.0, this is the line for minus 2.0 and 90. So here, can you see it? Then from 105, we are having it this way. And then for 120 degree is 0, we have it here. Then we have this one for 135 degree. 135 degree is giving us 1.42 again. Then 150 is giving us 2.0. So it should be somewhere here around 2.0. Can you see that? Then 165 degree at and 1.42, you plot that as well, is here again. So you can see how the graph will look like now. We can start plotting it from anywhere as convenient for us. Can you see that? So that is the graph of sine 3x equals to y. Now, just look at this graph, the way it goes. What if we now want this graph to continue this way to get to the x-axis? Where will it cut it? That is, where will it cut the x-axis? Let's assume that you are told that, okay, at the terminal point of this graph here, this point, where will it cut the x-axis? Let us see. So we now have it here to cut the x-axis from here. And if you get the value of this, definitely it's going to be 180 degree. It simply means that had it been that there's angle 180 degree here, so we have got the point as 0. So this is the graph of y equals to 2 sine 3x. Thank you for listening to today's lecture. So you have been so wonderful. Now we expect you to do this assignment and submit to your WhatsApp group before the week runs out. In fact, latest by Wednesday, you are expected to submit this graph. Just snap it and submit to your submit directly to me. That's to my WhatsApp number. So you also have some practice questions, and these practice questions will be set for your CBT this coming weekend. So make sure that you practice them, and this is just a flash of the practice questions. So you can pause it and get the detail. So thank you for joining us at Scholars Universal School Online. Please remember to subscribe to our YouTube channel. Remain blessed.